Hello, welcome to my first video on this series of differential equations. In case you don't know, if you're a speed schooler, I'm making one video per video that Dr. Tyler and Dr. Ralston made for their ENGR 205 course. So this video one corresponds to their video one. And I typically take example problems from them and put it in here and just go through it quicker than them and try to point out the big things. I know sometimes they go fast and kind of skipped what you were actually supposed to understand. So back to the video. So this first one's about linear DE. So for linear DEs, we need to consider two factors primarily. Is it linear or nonlinear, and the degree of the equation. So this is more of it's not really necessarily a concept of applying math type deal. It's more of a understanding and identifying it within an equation, because later on we will need to be able to use this to solve other differential equations and use different methods depending on whether or not it's linear or nonlinear or what degree it's to. So to be linear, each term in an equation must contain some f of x function times a y. That y can be to any degree of derivative. It can just be y, it can be y prime, y double prime, whatever. It doesn't matter. But if there is more than one y, regardless of the derivative or degree, in a single term, then the equation is considered nonlinear. So in order to be linear, you must have one f of x and one y. But if you have more than one y, then or some dependent variable, they can use things like t or v or u to mess with you. But if you have more than one dependent variable in a term, then it's considered nonlinear. So let's look at a couple of example problems to understand this fully. So for this first one, we have x squared y double prime plus square root of x y prime minus x squared minus 1 times y equals 0. So if you look at every underlined blue term is a function of x, so that denotes our f of x, and the green underlined term represents our y. Again, that first one's y, the second one's y prime, the second one's y double prime. And so if we see there's only one y per term and there's a f of x per term, then we can safely assume that this is linear, because it has one y per some function of x. So there's no exponential growth or any type deal like that, and there's not multiple y's per x. All right, so this next one's going to be a little different. If you look at our second term and our third term, we have a y and a y prime, and the second one has a y squared. So these terms denote that it is non-linear because you have a regular y times a y prime. Just because they're different derivatives doesn't mean that it can't be, doesn't mean it will be linear. It will still be non-linear regardless of what derivative it is, because you still have multiple y's within a term. And for the second one, you have y squared, still denotes that you must have at least one y. So this one will be non-linear. So look at the other factor that we have considered. The degree is basically looking at what is your highest derivative. So for both of these, 2, because we have primes as the highest one. If we made it y triple prime, y quadruple prime instead, then it would be to a degree of 3 or 4 and so on, depending on how high it is. It can be as high as you want, as long as that derivative is whatever number it's supposed to represent. Right down here in the blue explains it more. In case you didn't know, I'll be sharing all of my ENGR 205 notebook, so you can always follow along with whatever I'm doing and look at everything in case you don't. You need to look at it on your own without sound and be in silence. Really hope you understand this. Again, it's just understanding what you need to look for in each term and identifying it as to be linear, nonlinear, and degree. Please comment below if you have any questions. Thank you.